Hello viewers, in this video we'll derive the half-life formula for a second order chemical reaction. Now this is coming from the integrated rate law for second order. So this is given by 1 over the final concentration is equal to Kt, that is being added to 1 over the initial concentration, like that. So that's what we have. Since we are talking about half-life, half-life is the time taken for half the initial amount to be used. So we need to make Kt the subject of the formula because it's the one that is holding time. So doing that, what we are going to get is Kt is equal to, we'll have 1 over the final concentration, like that, minus 1 over the initial concentration, like that. So this is what we have. And then we proceed to say our Kt half. Now we're introducing half-life. The T half represents half-life. Now at half-life, we should understand to say at half-life, the final concentration, A final, is equal to the initial concentration divided by 2. So this is what we are going to have is our final concentration at T half or at half-life. At half-life, the final concentration will be equal to the initial concentration divided by 2. So this is what we are going to replace where we have A final at half-life. So it implies to say what we are going to have now is 1 over, where there's A final, we say is the initial concentration divided by 2, replacing, and this will be subtracted by 1 over the initial concentration, like that. So this is what we have at half-life. Now, let's work on what we have on the right-hand side here. Let's forget about the left-hand side for now. Let's focus on the right-hand side. What are we going to get there? So what we have on the right-hand side is 1 divided by A initial, that is being divided by 2, like this. And this whole thing here is subtracted by 1 over A initial. So this is what we have on the right-hand side. Yes. So doing mathematics there, we'll say what we have on this part here, on this part, is we have 1 multiplied by, we're going to switch those two, we'll have 2 over the initial concentration, like this. And this whole thing is subtracted by 1 over A initial, like that. Proceeding with this part here, that will just give us 2, 1 by 2 is 2, and then this is like over 1, 1 by this concentration here, which is the initial concentration, is going to give us 2 over the initial concentration. So this is what we have here, and this will be subtracted by 1 over the initial concentration again on the other side. Yes. When we reach this state now, our job is almost done. So what we do is we're going to find the common denominator. The common denominator in this case is just A initial. Since we have the denominators to be the same, so we'll have A initial as our denominator. Now, A initial will go once there, multiplied by 2, it will give us a 2. A initial will go once here, 1 multiplied by 1 will just be a 1, like that. So this whole thing here is giving us a 1 over A initial. So this is what we have on the right-hand side. So now, getting back to our writing here, what we have is Kt half is just equal to 1 over the concentration initially. That's what we have there. When you read this state now, all we have to do is make T have the subject by multiplying by 1 over k, so that the k on the left hand side can cancel. So after doing that, it means this k and this k will cancel, but this k here is to multiplying by this, and the 1 is to multiplying by that. So our final answer now, oops, let's take it on this side here. T half is equal to 1 divided by k multiplying by the initial concentration of A. So that's what we're driving, and this is the half-life formula for a second order chemical reaction. T half is equal to 1 divided by k, that is multiplying by the initial concentration. So we have it.